Chapter 7 focuses on logarithms, and we start the chapter by graphing exponential functions. So let's say we want to graph the equation y equals 3 to the x power, or in function notation, f of x equals 3 to the x power. I'm going to start off by making a table. I put x's in. I've just picked some x's from -2 to +2. I didn't pick them for any particular reason. We can plug in any x's that we want to figure out what this graph looks like. And when it comes to plugging in values, I'm going to start with 0, because that's usually a pretty good number to plug in first. So if I plug in a 0 to this function, we have 3 to the 0th power. Anything raised to the 0 power equals 1. So our first point on this graph is 0, 1. And this is a point that's on pretty much every exponential function, at least the parent function for every graph. So 2 to the 0th or 4 to the 0th would also go through this point, 0, 1. All right, let's do the positive numbers next. So we're going to plug both of these in. 3 to the first is 3. 3 to the second, or 3 squared, is 9. So that would give us these next 2 points. Okay, so the point 1, 3. Plugged in a 1, we got a 3. Plug in a 2, we get a 9. All right, now let's move over to these negative points. So if we were to plug in a -1, a negative exponent just moves it down to the bottom. So 3 to the negative first power just takes that 3, moves it on the bottom of the fraction, so we would have 1 over 3. -2 is an exponent, would move it onto the bottom and then square it, so it becomes 1/9. All right, so we fill those into the table there. So we plug in a -1, we have 1/3. Plug in a -2, we have 1/9. As we move farther out to the left here, it just gets closer and closer and closer to that x-axis. Right? It's called an asymptote in the sense that it's always going to get closer to that, but it's never actually going to touch it. So this is a horizontal asymptote, and it's at y equals 0 there. As we move to the right, it starts to shoot up really, really quickly towards infinity. Now let's take a look at f of x equals 2 to the x power. So we have our table. We're going to plug in values from -2 to 2. We're going to do this just like we did on the previous slide. I'm going to skip the math and just fill out the table. These numbers are calculated just like they were for 3 to the x power. So we get this graph. But let's say instead of this equation here, we have a slightly different equation. It's 2 to the x minus 1 power plus 3. Now this is a pattern that should be familiar to you at this point in the course, because we've seen this setup in pretty much every graph that we've done. We're always moving the opposite of what we see here, and then the same for what we see here. So basically we're going to take this red graph and we're going to translate it based on these two numbers. So they're going to move right 1, 3. All right, so we would take our table. This is just kind of the mathematical justification. If I were to plug in a number, plug in a 0, so I have 2 to the 0 minus 1, okay, because I'm plugging in up to this equation here. So I have 2 to the negative first. That moves to the bottom, becomes a 1/2. I add 3 to it, and I get 3.5. Okay, that becomes this point on the graph right here. So what we did is we took this point over here, which is this point on the graph, and it moves right 1, up 3, and it becomes that new point. All right, if we plug in another value, say we plugged in a 1, okay, 2 to the 1 minus 1 is 2 to the 0. Anything to the 0 power is 1. Add 3 and we get a 4. Okay, we put that on our graph. Oh, I plugged in another thing there. So if we put that on the graph, we have 0.14. That's our starting point right here. It moved over 1, up 3. Okay, this next one is going to move over 1, up 3. We already plugged it in down here. We got a 5. We can see that's where it ends up. All right, this one, if we move over 1, up 3, that's what we would get if we plugged in a 3. That would be at 8. And you can see here, if you plug in a 3, I'm sorry, it'll be at 7. If you plug in a 3, you'll get a 7. Okay, on the left, if we take this, we go over 1, up 3. We're going to be at 3.25. And this last one is not in our graph, but basically if we plug it in, we'd be at 3 1/8. So our entire red graph, just over 1, up 3, we get this new blue graph right here. The asymptote is changing also because the asymptote moves up 3, and it's a horizontal asymptote at y equals 3. So that being said, these exponential functions transform just like every other graph that we've done, namely by changing these numbers here. Okay, we move opposite of that h in the x direction, same as the k there in the y direction, and if we have a coefficient in front of that exponent, the base of that exponent, it's going to be a scale factor for the graph, so it's going to make it larger, okay, or maybe shorter if it's a fraction. In this example, we have 2 times 4 to the x plus 2 power minus 3. The first thing we want to figure out is what's the actual parent function. The parent function has to do with what's the exponent attached to, and in this case, the x is attached to that 4. So the parent function is y equals 4 to the x power, and we're going to start off by graphing that. So we're going to plug in negative 2 to 2 for those x's. So attach those as exponents to the 4, and we get these values. Okay, not all of these fit on the graph. So for example, 216 doesn't fit on the graph. All right, however, this one, for example, 1, 4 would be this one right here, 0, 1, okay, is this point right here, etc. Next thing we want to do is apply the scale factor. This always comes second. Okay, so that 2 is going to double all of our y values. So let's say we took this point right here. Okay, it's going to get twice as big. And when I say twice as big, it's only applying to the y value. So this is 0.01. The y value is going to get twice as big. So the 1 becomes a 2. Right? When we look at this point, the 4 is going to become an 8, etc. So that first red point that's circled there, is going to become 1, 2. That next red point becomes 1, 8, all right, etc., etc. All of them get twice as big. Okay, so now we have this blue graph, and the blue graph is going to move left 2, down 3. So each of these points are going to be replaced with purple points, move left 2, down 3, left 2, down 3, okay, etc., etc., until you've moved all of them, and this is our final graph. We can see the asymptote there. It's going to be at y equals negative 3. That's the horizontal asymptote for the graph. So this last one, we're going to do the same way, but it's going to look a little different. First step, figure out what's the parent function. Parent function is whatever this exponent x is attached to, which is 1/3 to the x power. That's our parent function. We're going to graph that first. Let's fill out our table. Negative 2 to 2 for the x's. And I'm actually going to plug them in this time. So 1/3 to the 0 power, again, we get a 1. I'm going to put that on the graph over there. If I plug in a 1, I have 1/3 to the first power. That's just a 1/3. Okay, if I were to plug in a 2, 1/3 squared is going to be 1/9. Right? If I were to plug in a negative 1, okay, this negative would go to both of the things inside this fraction. So it goes to the top, goes to the bottom. They both switch spots. Okay, the top goes to the bottom goes to the top, and I end up with a 3. All right, same thing if I put a negative 2 up there. Both things would switch spots. We would have a 1 squared on the bottom, 3 squared on the top. All right, so unlike the last two graphs that got bigger as we went to the right, this starts big, it's big on the left, and as we move to the right, it gets smaller. And it gets really close to that x-axis without ever actually touching it. So we have this red line, that's our parent function, and now we're going to apply those same principles that we did for all these transformations. So we have a 2 as a scale factor. That's going to double all these. So the 3 is going to become a 6. This is going to become a 2. This would be an 18, but it's off the graph. All right, so all of these y values double. We have this blue set of dots here now. All right, now that we have those blue ones, we're going to translate it based on these numbers here. So we're going to move right 1, up 2. Okay, so take this blue point, move it right 1, up 2, and we're at that purple point there. Same thing with this next blue one, right 1, up 2, okay, on and on. And we have these purple points, which give us our purple line there. Okay, we can see the asymptote has moved from the x-axis up 2, and it's now at y equals 2.